Good morning and welcome again to the Managed Aquifer Recharge Systems and Water Harvesting Techniques course promoted by the University of Sassari. In the lecture 5 and last, we are going to talk about SUDS, or Sustainable Urban Drainage Systems, types and functions, applicability recommendations, examples of real cases, exercises, and additional materials. Let's talk about the urban water cycle. Let's attend these infiltration rates below a rural area and an urban area calculated by UNESCO. For the first one, the infiltration rate is something between 40 and 80%, and below a city, the infiltration is between 1 and 30%. So there is a direct impact on the aquifers. This mock-up reinforces the idea of happy water below a rural area and unhappy water below a city. This slide, also taken from UNESCO, displays the large amount of pollution sources that can affect groundwater below a city. So, actions in urban areas tend to reduce the runoff volume and to break the heat island effect. Some good practices in cities to minimize the surface runoff are the drainage towards gardens or green areas, the storage of rainwater to be used later, the growing of sustainable urban drainage systems, minimizing the use of agrochemicals in parks, and education oriented to agents involved in cities design and management. Of course, there is an etc. too. Now let's talk about the Sustainable Urban Drainage System, or SUDS from now on, types and functions. They are based on the 3-axis rule: slow it down, spread it off, and soak it in. Of course, it is talking about water. So, SUDS are low-cost water harvesting implementation unit to achieve a greater infiltration by permeable paving. The justification of SUDS is for urban water cycle, the runoff increase and less infiltration, the heat island effect, by impermeability and temperature rising, regarding climate change for misadaptation, regarding urban environment for the loss of biodiversity, and the economical cost is related to infrastructures and natural disasters. Two reasons to justify SUDS: the evacuation time. This slide is very representative of the problem, and the rise of temperature, of the heat island effect that we have already mentioned. Where can be applied SUDS? There are some possibilities related to planning: green roofs, parking lots, winter roads, water storage, pavements, urban elements, land containment, roads, large areas, to finish by education and prevention, so it can be applied everywhere. How? By means of recovering the natural water cycle, improving the water quality in the city, protecting the urban area against floods and droughts, allowing the development of saturated areas, and also adding aesthetic values. These targets may be included in the source control, in the infiltration conveyance, in the passive treatment and storage, and in the prevention. Regarding applicability recommendations and possible applications for concave edification in a smart city, it is important to take into consideration the general aspects: the water storage in the city, the paving, the urban elements, roofs and vertical gardens. There are some slides as examples of each chapter. Parkings, winter parkings, containment structures, ways, and bylaws some facilities to improve the water quality in the city. The technical approach is different for each specific case. There are recommendations for infiltration trenches, for a check dam, for filter trench, and for a bioretention area. All these examples are displayed in the references at the end of this lecture. Holding the line of the previous slide, there are specific recommendations for infiltration trenches, impervious pavement, partial infiltration, for infiltration basins, and even for roads. So, in the design, you decide about which SUDS manages rainfall most effectively, which one will be the most durable, which one is easiest to maintain, which option is the safest, and the causes and benefits. Some examples of real cases, most of them from the Spanish territory, are the Parvic in Majorca Island, when there is a green roof and facade with infiltration well and ground detention basin. Some architectonical designs in Catalonia have infiltration parking lots and infiltration trenches. In Aranjuez, Madrid, the architectonic designs include detention ponds and the filter drain. And for the last example, in Doñinos, Galicia, green roofs and detention basins were constructed. This is a representative example of concave edification. Where is the water in this roundabout going to? This is a representative example for the conversion of a roundabout as a storage area, talking about concave edification. The same philosophy or idea can be applied in winter parkings and in green roadsides. Another example for Gomeznarro in Madrid, Spain, is the drainage of a part avoiding the flow to crash into a building. This construction also stored a huge volume of water for the later infiltration in the aquifer. Most of the exposed elements are described in the Water Harvesting Techniques in Urban Area book, titled The Comprehensive Management of Rainwater in Built-Up Areas. In order to finish this lecture, we propose 3 exercises on SUDS. The first, to calculate the amount of water retained in a unique vegetal cover. In the second, we'll calculate the concentration time and the evacuation of the water from a runoff trap connected to a highway. And in the third, we can calculate some approximate budget of some of the actions to be done. As additional materials, there are proposed 3 references of books and videos, reminding students that an extended version of this presentation is posted in the MEIA website. Good luck and thank you very much for your kind attention. See you next course.